Good afternoon. I hope everybody had a good lunch. Let me get my time out. So let's get going. Hello, my name is Scott. I go by Tan Newt online, which is the third bullet, but that's fine. I work for a company called Adafruit. They're based in New York City, but I work remotely from here in Seattle. They do open source hardware and software, and we'll get into what that is right now. So for example, we have a clue board. This is like how big it actually is. But let me give you a quick tour of what that means. So there's these little, so this is the back of the board. A board is like a printed circuit board where a bunch of components are wired together using a printed circuit board. So let me give you a quick tour. So first there's a USB plug at the top. So you can plug this into your laptop or desktop using that. On the right, there's under that metal dome, there's a little tiny computer called a microcontroller. It is 48 to 100 megahertz. I forget what this one actually is. But you can get up into the hundreds of megahertz, which is quite cool. But they are not desktop computers. These are microcontrollers, and they're used generally to interface with the real world. The other cool thing about this is this has an antenna. This antenna here is for BLE, or Bluetooth Low Energy. So this is typically how you would connect your phone to your headphones, for example, or your watch. That's using BLE. Okay, so I want to introduce you to CircuitPython by just kind of giving you a glimpse of how it all works. So first, what you want to do is you need to get CircuitPython on the device that you got. So you go to circuitpython.org. Here's our nice landing page that our designer put together. I still think it's true. It's the easiest way to program microcontrollers, so I'm very proud of that. And that's what we'll talk about today. So if you want to get CircuitPython, you go to Downloads. Once you're at Downloads, we have a lot of different boards that we support. We tend to sort them by popularity and then by alphabetical. So Clue's not really at the top. So we'll type in Clue, and now you can see that there's only one type of Clue board, so you just click that. Once you click that, you can download a UF2 file. This is a special file that makes it easy to get the kind of binary from your computer onto the microcontroller device. This is the equivalent of like your python.exe or your Python executable you would have on Mac or Linux. But you're getting it onto a separate computer. You're not using it on your own. So let's get it on there. We're going to plug in our USB into our hub. We're going to plug our USB into the Clue. And once it's plugged into the Clue, what we want to do is we want to double tap the reset button. Once we do that, we'll get a green light on the back, and that says that, hey, the bootloader, whose job it is to get software onto the device, is ready for you to do that. So once that happens, you can open your file manager. This works across OSs because it's just like a USB thumb drive. You get a Clue boot or something boot drive that you get, and the UF2 file that you downloaded, you want to drag it over there and copy. Once it's done copying, it will automatically reset into the new software. If you're on Mac, don't worry, it'll complain that it ejected too early, but the bootloader actually knows how much data it's waiting for, so it knows ahead of time. Once you do that, it restarts into CircuitPython. Once you're in CircuitPython on a USB native device, you get a CircuitPy drive. You actually notice I had two plugged in at this time, so I clicked the right one. That's in the bottom left here. And then also on the drive, you have a code.py file. So this is where your source code lives. This is on the device itself. So you could give the device to someone else. They could do this process, and they'd have your human readable source code. I think that's incredibly powerful and incredibly cool. But of course, I'm biased. Once you click that, we ship with the default hello world just to get you going. You say, OK, we have hello world, but where does my hello world end up? So you have to open a terminal or use another program that does it kind of one and the same. I like to do it via terminal. There's a cool app called TIO. This is kind of like Screen, but it reconnects for you. And then if you're on Linux, pro tip, you can do the dev serial by ID and then use the name of the device instead of some random number. Here you can see that it automatically reconnected for me, which is really cool. But after that last connected message, it didn't show anything. So if this happens to you, it can happen if the USB connects after the user code has started. So what you can do is Control-C to stop the user code from running, and you'll get a nice prompt here. This is the REPL. So this is like if you were to run Python on your computer, but this REPL is running all on that device. So the device is doing all of the parsing that is needed to go from human readable Python to code that's running, all in the device, and that's incredibly cool. It also means you don't have to install very much, which is also helpful. If you're in the REPL and you want to go back to user code, the code.py, you can do Control-D, and now you can see that we have Hello World running. So let's change what Hello World does to Hello PyCascades, and I will save it. And once you save it, the device detects the save, and it automatically reruns the user code. This is incredibly powerful and convenient, if you ask me, where it automatically reruns your code. So that was a quick introduction to CircuitPython and how it works. That is what I would call the USB workflow. So if you have the ability to connect over USB, you have a device that allows you to show up as a CircuitPy drive, that's your experience, and that's what people kind of know for CircuitPython generally. But I've thought a lot about broadening what we can connect to CircuitPython devices and how we can program them, and that's what we're going to talk about today. But before I do the other ways of doing it, I want to just break down what a workflow is. First, we installed it, and then we got file system access. So not only were we able to edit a file, but theoretically we could drag files over and copy files over, just as if it was a USB drive. And then lastly, we also connected to see the serial output so we could actually do printf debugging. Those are like the three kind of core things that you have to be able to do to what I think of as a workflow. So when you're thinking about a workflow, you have to think about kind of two things. One is, what devices are you trying to program from? This works really well from a desktop and a laptop. But if anybody was here at PyCascades in 2020, I did a talk about how the future of computing is actually mobile devices because they're just selling way more of them, and that's the computer that people start with. So the question is, like, what is a workflow for CircuitPython or programming in general where you're doing it on a phone or tablet? And then for CircuitPython devices, it's a question of how can you connect to them. Do they have native USB? Do they have Bluetooth Low Energy? Do they have Wi-Fi? Those are the main things. So Bluetooth, the USB thing I think is really compelling. It's great, but you have to have it plugged in. Bluetooth Low Energy is really good for on the go. So for example, my watch here is actually running CircuitPython, and it's connected to my phone right now. I can pull up my source code from my watch on my phone right now. It's very great for on the go. Wi-Fi is really good if you're in your house and you have a bunch of sensors and you don't want to have to like track them all down. You could just kind of say, hey, who is out there, and get all of them and do that. I gave more details about certain chips, but I'm not going to go over that. That's just for reference. So we're going to have this little diagram here about kind of the state of the world for CircuitPython and the workflows. We have no support, partial support, or fully supported. And then also whether it's like the API to make it happen or whether you could do it from desktop and mobile. The USB workflow really benefits from having a standard API, you know, a USB disk, and many programs that already know how to interact with that. But that's not always true when we're talking about different connectivity options. So we'll talk about that. So today I want to cut the cord and talk more about Wi-Fi and Bluetooth Low Energy. How do you program CircuitPython with that? A lot of folks I've shown this to so far are being like, I didn't realize you could do that. And I want people to think about this and see what possibilities it opens up for you. So first we're going to do kind of the combination of Wi-Fi and desktop/laptop/browser, and then we'll go into the Bluetooth mobile world after that. But first, we have to get CircuitPython on these devices, and unfortunately, we don't have a really good way of doing that initial step over Wi-Fi and BLE. Our assumption is basically that you still have to plug into USB to get it loaded, and CircuitPython loaded and your credentials if you need to up front. There are like a few cases where BLE and Wi-Fi you could load code, but generally, it's not as easy as just plugging it in kind of for that first go. But I'll show you the process. For CircuitPython.org, there are cases where there are Wi-Fi chips that don't have full USB support. They have limited support where you only have like serial connection, which is characters back and forth. So I'll show you a really cool tool that we've added to the CircuitPython.org downloads page. And this was not done by me. This was done by my coworker, Melissa, who's done a great job with this. So here's another board. I brought this, so for size, it's also teeny. This is a Wi-Fi board, and it actually has native USB too, which is nice. But if you want to talk to it without the USB cord, here's what you can do after this install process. So if you scroll down on these boards, there's an open installer link. So click that, and oops, I'm in Firefox. I use Firefox day to day, but this uses more experimental web APIs that the Chrome folks have pioneered. Particularly web serial and web Bluetooth falls in that category too. So we're going to switch over to Chromium, and now we have some options. We can do a full install, but we could also just update our Wi-Fi credentials. How many of you have had that experience where you have to get it in this mode where you have to connect to the Wi-Fi of the device and then give it credentials for something else? In my opinion, that's a huge pain. So instead we just say, we'll just handle it for you when you get CircuitPython on there. And you can do it over serial. It's much more pleasant than losing your internet, in my opinion. So this tool is experimental, but it's working quite well, in my opinion. That's just a heads up. Now, your browser needs to get access to your serial connection. So once you click connect, if you have TO open still, it will conflict, so you have to make sure that nothing else is talking to it. After that, you can select a drop-down that's really hard to capture because it goes away. But you'll notice in the tab there's a little logo that the serial is now connected to the browser code. It will overwrite everything, so make sure you've backed up anything that's on there. It will erase the flash CircuitPython. And then this is actually a native USB device, so it will come up as a boot drive. The browser can also have access to folders. Okay. So that is, okay. So you can use the browser to select that, the boot folder, and now it can do anything within that folder. And the browser will confirm that you want to do that. Here, it will download the UF2 again. I honestly don't know why it does this, but it works okay. Now you can select the CircuitPy drive, and it will install your Wi-Fi credentials for you over that drive too. How those Wi-Fi credentials are on your drive is there's a settings.toml file. So in that same place that we had the code.py, there will also be a toml file. This is kind of our way of having an environment as you would on your desktop. So you can access this from your user code using os.getenv. The CircuitPy underscore ones are ones that CircuitPython itself will use. So if you give it SSID and password, it will auto-connect to your network. If you set web API password, it will automatically start what we consider the web workflow, which is 2 pieces, or 3 pieces. It's an MDNS server that makes it easier for discovery that we'll see in just a bit, and also an HTTP server for a REST API. And that's why it starts. So once you do that, once you've done that install, you can go in your browser and you can do circuitpython.local. You may not have seen that before, but that actually does local discovery on your network using MDNS, which is the same technology that your phone uses to discover a Chromecast or iOS or like Apple TV or your printer. That's all through MDNS. It doesn't always work on a network, but when it does, it's quite magical. So the server at circuitpython.local, all of the devices will respond to it, so you're only guaranteed to get to any one of a number of CircuitPython devices. So once you get to there, it will redirect you to the local domain for that specific device that you got to. And that device will then also discover at the bottom all of the other CircuitPython devices on your network, so you can get to the one that you wanted. This is not the one I want. The Pimoroni Inky frame is not what I want. I wanted the S2, so I'll click that, and now my browser has taken me to the device that I want. There's a file browser link here, but first I've got to enter my password. I just wanted to show this because you don't enter anything for your username. You just put the password in that is in that settings.toml file. Don't use anything important. It is not like actually encrypted in your local network at all. It's just meant to raise the bar a little bit if you have like a group full of I think of as like a classroom full of kids. It's just meant to raise the bar a little bit to make it a little harder for somebody to like hack your device. But don't use anything important there. It's just meant to be a little hurdle. After that, you can list all your devices or all of your files, and you can see that there's code.py. It's giving a warning now that USB is connected. So this is a case where we're doing kind of two workflows at once. So what I had to do is I have to eject my USB drive, and once I do that and refresh, now I can edit and rename and do all these file system-y things through the web browser. And this is all hosted from the device, so it doesn't matter if you have internet or not. So if you hit edit, you get this lovely, lovely code editor, or text editor, let's be honest. But it is also fully offline. So you can use that, but if you want to use something cooler and you have internet, you can go to code.circuitpython.org. And this works for Wi-Fi, Bluetooth, and USB. So in that same way of like, tell me what folder you have, it works over USB. If you have Bluetooth, you can actually use this from a Chrome browser too. We're not going to get into that today. But if you have a device on your network, you can do the devices domain/code, and that will get you to the point where you can edit from that device. So code.py, just like last time. And now we'll hit save and run, and we get the terminal on the right-hand side. We see hello world. I switched it to hello PyCascades 24. Now I'm going to hit save, and the same thing happens, but now it happened over Wi-Fi instead of over USB, which I think is pretty cool. So that is a quick, breezy tour of Wi-Fi workflow from kind of like a desktop browser environment. Mobile is more challenging because you generally have specific apps for things. So let's do a quick tour of apps. But first, we're going to, well, we'll select the glider, but our device is not on here. So we have to get the device into pairing mode. Once to get into pairing mode, if you hit reset, CircuitPython will blink yellow and then blink faster blue. You hit reset during that fast blue period, and it will go into discovery mode, which you've probably, if you have anything Bluetooth, you've seen this. Make sure your device is really close. It's not super strong broadcasting at that point. Again, trying to raise the bar a little bit for somebody else to get access to it. Once you do that, you'll see a new device is discovered. It will ask you to pair. This gives it more permissions and access. Once you do that, you can explore. So this is the File Glider app, which I didn't introduce. But this is the file system part of the workflow that I was talking about. It does two things. It gives you a basic file system view here, along with a basic editor, but it also integrates with the OS's native file system format. So the Files app can show things, and other third-party apps can actually interface with files through the Files API. It's available on Android and iOS. And here's the file. This is my watch code, I think, or some other test code. We're going to keep going because I got a lot to cover. So Files app, you can hit locations. You get a glider location. You see your devices, and we have a bug here. Sorry. It doesn't load for some reason. We're going to figure out why, but this would be the Files API integration. For Serial, we have an app called Bluefruit Connect. You select your device, and you get the CircuitPython option. Once you have the CircuitPython option, you get the serial, but you have the same blank problem, potentially, if your user code's already running. We don't give any like informational serial things when user code's running. So you can Control-C and Control-D and get back to there. Last up, we have I just wanted to plug this quick PyLeap app. This is meant to get you started really early, so you can get a project, you could download it to your device real quick. It's also available on Android and iOS. Behind the scenes, the BLE workflow, there's workflow documentation, so all of the APIs that you've seen used under the hood are openly documented. I'd love to see folks create new tools. The BLE workflow is a kind of a standard UART service, but we've changed the UIDs. We have a custom file transfer service. For web, we have a WebSocket for Serial and an HTTP REST API if you want to hack on it. So in the end, we've covered a lot of these bases for programming CircuitPython wirelessly. But if I'm honest with you, as I showed, there's a lot of bugs here still, unfortunately. And so I need your help. I need folks to know that they can do this, which is why I'm here. Use it, play around with it, find issues. We want to find those issues so we can squish them and get more people using this, because it really does open up programming to a lot more people than just those that can plug in over USB. 2 more slides, I think. Thank you. App source links. So if you do want to get into mobile development, you want to help us squish some bugs, it's all open source. I'll have a link to my slides in just a second, so you can click those blue links. But all 3 of these apps are open source for both iOS and Android. Quick shout out to Antonio and Trevor, who did the mobile apps, Melissa, who did the web stuff, and Liz for all the testing, making sure we don't have as many bugs as we do. And this is the final slide. So if you want to know more about CircuitPython, you can go to circuitpython.org. I'm going to be hanging out here, and then also there's a link to my presentation slides. You can find me at Tan Newt online. Tan Newt on GitHub/presentations will have all the presentations I've done and the slides for them. Thank you. Thank you for having me.